Hello participants, I welcome you to the lecture 29 of micro irrigation engineering subject. This lecture is on fertigation application methods. We discussed in previous lecture 28 about the importance of fertigation, different types of fertigation fertilizers, and in this lecture we will discuss about different devices which are used to apply fertilizer using these devices. So, in this particular lecture, the methods of fertigation application, relative comparison of these methods of fertigation methods, and how to design the fertigation system will be dealt. So, when we are applying fertilizer or chemicals which are dissolved or soluble in water, this can be applied through using Venturi injector or by using pressurized fertilizer tank, where there is arrangement of bypass system, or using an irrigation pump. So, these devices are used. Let us discuss in detail about all three types of devices, how do they function. So, as the name says that it is a Venturi injector. So, Venturi, you know that there is a constricted passage. There is a constricted passage, and in this passage the water or fertilizer solution is being sucked. So, the high flow velocity of water in the constriction, it reduces the pressure. I will show you the diagram where you will see that why the pressure get reduced and velocity increases. So, this pressure, it becomes subatmospheric pressure. So, fertilizer solution is sucked from an open tank into the constriction through a small diameter tube. The process of injection of fertilizer can be explained by using the energy equation, which is involving the Bernoulli's principle, and assuming inlet and outlet ports of the Venturi are kept at same elevation. So, if you look at the Bernoulli equation, the Bernoulli equation is the pressure head plus velocity head plus elevation head is constant. Means, when we are taking, if any particular head is reduced, the other component increases. This is the basic principle, because the right side of the equation is constant. So, suppose elevation head is 0, then pressure head and velocity head equal to constant, or we can say when the pressure head is less, the velocity head will increase. So, the different means your symbols here it is used. P refers to the pressure, V refers to the velocity, Z refers to the elevation, and this is a gamma which is a unit weight of water, and G is acceleration due to gravity. So, rate of flow in the Venturi system, it can be regulated by using the valves. So, here there are valves, and these valves this can be this could be means regulated so as to allow the water. So, this is what you see here, how the water is being supplied along with the fertilizer. So, this is a fertilizer container, and then using this venturi it is attached here. This is the venturi which is attached, this part is venturi, and this is attached, and this fertilizer solution is sucked by using the venturi, and then it is entering into the. So, this is a simple device, and as such it is inexpensive method of fertilizer application. And when you look at the diagram, just for few minutes you will see the concentration it is increasing, and then it goes to almost a constant, mean there is it goes to a constant value of fertilizer concentration after certain time. Now, the concept of Bernoulli principle, it is explained here that considering an inlet. So, this is the inlet part, and this is kept in a same elevation, means this particular venturi section it is kept in the same elevation. So, initially the equation was pressure head plus velocity head plus elevation head was equal to a constant. Now, we are taking two sections. So, one section, this is your inlet section of the venturi, and this is the throat section. So, at this inlet section, pressure head plus velocity head equal to the pressure head plus velocity head. Now, what is happening? The pressure head, and say P is the pressure head at the inlet section, P 1 is the pressure head at the inlet end, and V 1 is the velocity head. So, at this point what happened, because of the constriction, this your area of the flow reduces, that causes increase in the velocity of flow, and there will be a condition when this pressure head at this point it will become subatmospheric. So, fertilizer which is kept in this tank which will start injecting into the system. So, this means P 1 over this pressure head between the two end can be given by change in the velocity head. So, change in the velocity head due to constriction in the venturi pipe causes suction due to change in the pressure head from P 1 to P 2, that is below atmospheric pressure, thereby the suction of fertilizer solution will take place. Now, we are demonstrating you here for testing a venturi injector. This is a venturi injector. Now, a venturi injector is used to inject chemical. This is used to inject chemical. This chemical could be a nutrient which is soluble in water, and that is being injected into the drip system. Now, what a typical drip irrigation system, if you remember, we discussed that the water is taken from the source. So, in the laboratory setup, we have got a sump where water is stored, and then the water is being pumped by using a electric motor coupled pump, which comes that is this particular component is the suction end and that is the delivery end. So, water which is coming, that at what pressure. So, pressure gauge is mounted, we can know that how much is the pressure available. Then this part, if we are not injecting fertilizer, then the water can be directly, it can go to the main pipeline. So, here it goes to the filter and from filter it will go to the system. There is a water meter attached to this one. So, how much amount of water is passing. Now, if we want to inject fertilizer, so a Venturi injector is connected. Now, Venturi injector, this is a demonstration setup, we can test that how much amount of fertilizer or chemical or nutrient can be injected at a given pressure. So, this is one pressure gauge, this is the another pressure gauge, and with the help of these two valves. So, pressure is regulated, and so this particular place where there is a reduction in the diameter of pipeline, this causes the increase in the velocity of flow, that will decrease the flow, decrease the pressure, and thereby a suction will be created, and due to decrease in the pressure or increasing the suction, the Venturi will function and then it will start injecting fertilizers. Now, you can see we are regulating the pressure, and when we are regulating the pressure, we are opening the knob. So, fertilizer has started injecting into the system. So, at a given time the volume of water, because this is a graduated cylinder, one can know that in a given time how much volume of fertilizer it has been injected into the system. So, for a given pressure, this is the pressure reading, and then what is the rate of injection, that can be calculated. This is a simple device, there is no moving part, easy to install and maintain, suitable for very low injection rate. Injection can be controlled with metering valve, and this is suitable for both proportional and quantitative fertilization. Means proportional, I mean to say that water and fertilizer ratio, it can be proportionality, it can be maintained, as well as the desired amount of the fertilizer, it can be given with this method. The disadvantage of this system, there is a considerable head loss due to constriction and then attachment, which causes. So, sometime it requires a booster pump to create adequate head to supply fertilizer along with irrigation water. Quantitative fertigation is difficult, and then moreover the automation is also difficult when we want to give fertilizer along with irrigation water. There is a pressurized fertilizer tank, which here it is given named as also bypass system to supply fertilizer along with irrigation water. So, here what we see from the diagram, let us try to understand the this is a tank. In this tank, the fertilizer in this means it could be in the liquid form or solid fertilizer, which is soluble. It is the water is supplied from this end. So, there is a flexible pipeline, and then this place there is a one valve. So, water from this pipeline, which is coming from the pump, can be supplied with the help of this flexible pipeline, which is connected with the inlet plunger pipe. So, inlet plunger pipeline is perforated. So, water which is coming, it will be getting into the tank. Now, this tank is airtight, it is completely made it that the air cannot enter into the system, and then it can be opened or capped. So, there is a gasket arrangement where with the help of a lid it can be tightly closed, as well as and when it is needed, it can be opened. There is a if there is a air inside, so there is a bleed valve. This is a help to remove the entrapped air in the this pressurized tank. Now, as when the water is being continuously flowing into the system, what will happen? It will mix with the fertilizer available in this particular pressurized tank, and then there is a inlet end where there is a strainer filter or strainer screen, which is of some certain mesh. It is kept in this particular place, and then so that the dissolved fertilizer which is in the soluble form, it can get into the system, that is your irrigation system. So, it is allowed to go as long as we keep on allowing the water to get into the system. So, this is your inlet kind of a thing, and this is the outlet end of the thing, which will be allowing the fertilizer solution to get into the pipeline system. So, this is a pressurized fertilizer tank, and then there is a inlet and outlet end. Now, the another important part is your pressure reducing valve. So, pressure reducing valve is operated in such a way that it will allow the pressure to reduce, so that the pressure inside the tank is more than the pressure here at this in the pipeline. Then only the soluble fertilizer, this can be in the liquid form, it can be supplied with the irrigation in the pipeline, and then it will go to the strainer filter or some other filter, whatever it is there, it goes to the pipeline. So, here it is given the rate of flow of solution is determined by the pressure difference between the inlet and outlet points, and is monitored by a flow meter. So, flow meter is another device which is used to monitor how much amount of the fertilizer and how much amount of the water is entering into the system. The difference in the pressure between the connection and constriction in the pipeline is sufficient to cause flow of water through the tank under pressure. This is the thing which I explained here, which I told you. The gradient of 0.1 to 0.2 bar is required to redirect an adequate stream of water through connecting tube of 9 to 12 millimeter diameter. There is a airtight pressure supply tank is required to withstand maximum operating pressure. So, this is the part which I was telling you, there is a airtight system, and then the tank should withstand the pressure which is the water which is entering and the water which is going through the pipeline. So, it should be more than the pressure inside the tank. So, tank should withstand that pressure, and then the precise control valves are necessary to maintain a preset injection rate. So, the amount of water which is entering into the pipe into the tank, the amount of fertilizer which is coming out of this thing. So, that is the rate of injection, it can be maintained. The fertigation is cheap and simple. A wide solution ratio can be attained with no external source of energy. You can see here, this is the arrangement which is shown in the field. There is the one end, the water is getting into the system, and then it is coming out, and then there is a filter. After it passes to the filter, then it goes to the pipeline. So, this is the arrangement where this is a pressurized tank which is kept on a concrete platform, and then the fertilizer is kept into the system, and then the flow of water is maintained such that the fertilizer it can be injected. What happened? There is a continuous supply of the water in the tank. So, there is a dilution. So, concentration initially it reaches to there will be dilution when we are injecting water into the system. So, it reaches the concentration, but slowly it start dissolving and then concentration with time it decreases. So, it is unlike in case of Venturi injection. Here in this case which we are seeing here, this is a vertical model. So, there is a here there is a water, the water is filled into the system and then inside the this flexible your bag, in flexible bag the fertilizer solution is kept, and then when we are supplying water into the system, it is pressing, and so that the depending on the pressure, the amount of fertilizer will be coming out of the system and that will inject into the pipeline. So, this is the one model, and this is the normal model which where the water is coming, it is getting into the system and then it goes. That is what I explained you in the previous case. So, there is a proportional models which are generally vertical tank with the sizes varies from 10 to 300 liters. That will depend upon the capacity of the or amount of fertilizer one has to inject into the system. If it is a smaller system, one should keep on refilling the solid fertilizer which are soluble in the water. The quantitative models could be of 5, 30, 60, 90, 120 liter capacity, and then this can be made horizontal or vertical tanks that can be used. Nutrient cannot be precisely regulated to each application. This is what I told you, that we cannot maintain the correct concentration. So, there is all the time dilution takes place. Wall throttling generate pressure losses and the system is not straightforward. It cannot be coupled with the automated irrigation system. Only thing that this is a simple system and there is a low cost, no external power is needed and relative insensitive to the changes in pressure or flow rate. However, the tank must be strong enough to withstand the pressure of the irrigation line. There are limitations. These limitations are: there is a varying concentration of nutrient causes bulk of fertilizer to be applied at the beginning of the irrigation cycle. So, initially it is getting more concentrated fertilizer and then it diluted. So, tank must be refilled with the solution for each irrigation cycle. The system is not suitable to connect with automatic or serial irrigation system. There is a injection system, means it involves the pumps, and then pump is used to inject fertilizer solution into the irrigation system. This is relatively the more sensitive to concentration, one can maintain the concentration in the system. So, solution is fertilizer solution is pumped from unpressurized reservoir. So, this is a reservoir where the fertilizer solution is filled, and then it will depend upon the what type of pump we are using. So, that is making the difference. So, it is dependent on the power source. The pump, this particular pump which we are using to inject the system, it could be by using the combustion engine, or it can be electric motor driven, or the PTO of the tractor that can be used, or hydraulic pressure or water engine. So, this is here hydraulic pressure type of system is being used. So, what we are seeing here, when the fertilizer is to be injected. So, there is a the piston, there are the reciprocating motion, it takes place. So, when we are seeing this is the position of the piston. Now, this piston, what will happen when the flow of water it is taking place. So, this flow of water, what will happen, it will push the piston, it will go back. So, this will cause the closing of the valve, and then at certain position when the fertilizer is being sucked. So, when the fertilizer is being sucked, it will come, then the fertilizer will inject here, the piston will come down, and then it will make the fertilizer to move up, this particular piston to move up, and then it will close. So, continuous kind of a flow it will be. Once it is coming down, so this will push whatever fertilizer it has injected, it will push, and then this liquid fertilizer it will be pushed into the system. So, there is a system where water as well as fertilizer dissolved with the system, both are introduced and these are maintained in a proper proportion. So, this is a fertilizer proportional system where means reciprocating type of system, where double acting pistons are used to make it. So, pumping rate and concentration of the stock solution can be adjusted to attain desired level of fertilizer application. This could be operated by electric engine or pulse generating water meter, so that the fertilizer injected is exactly proportional to the water flow and constant concentration is maintained. Automatic computerized control system are also available to provide exact rate of injection into the water flow. And what we see here, there is a means after certain time when we are introducing. So, water is initially the water is getting into the system, into the tank, and then it is reaching, and then there is a constant rate of concentration is maintained. So, this is the advantage of using the pumps to inject fertilizer along with irrigation water. There are advantages, there is a flexibility, and one can maintain high discharge rate, and then system does not aid to the head loss in the pressurized system. This is irrigation, this is the advantage. It maintains a constant concentration of nutrient throughout the period of fertilizer application, and this is a desired in many cases, particularly in hydroponic system, where the concentration of certain nutrients which are needed, which should be at the constant rate. So, there actually this kind of a system is desired. The limitation or disadvantages, we can say it involves the cost, unlike the Venturi system or the pressurized tank kind of a thing. It is having the operational cost, because cost of the electricity and maintenance is required. Now, let us compare the different methods of fertigation which I discussed. I discussed about the bypass tank or bypass the pressurized tank. We discussed about the Venturi injector. We just now I told about the fertilizer pumps, injecting pumps, and then these are the parameters which we are interested to compare these things. So, taking the parameter as ease of operation, bypass system is it is a highly easily it can be operated. Venturi system, it is one should take care that whether there is a enough pressure difference is created, then only the Venturi will be sucking the fertilizer. So, this is one thing, and then the from the operational point of view, it is low, there would be situation where there is it is easily this is easily operated, and then use of solid fertilizer. Yes, one can use the solid fertilizer, and then because water is entering all the time. So, that gets dissolved time, but in Venturi as well as fertilizer tank, one cannot use the fertilizer tank, one cannot use the liquid fertilizer is required, that is essential for the in all the cases, and it is very easily. Discharge rate is high in case of bypass arrangement. In case of fertilizer pumps, it requires the high discharge rate. Venturi injector, it is relatively low. Concentration control, we cannot have any concentration control, it is initially high and then it start dilution because we keep on adding water. It is a medium and it is a good. Volume of volume control, it is a good, medium and it is a good. Head loss, there is a low head loss and then there is a very high head loss takes place from the system and there is no head loss as the pump is being used. Automation, one cannot use this system for automation. This can be to a certain extent, but here also it is, but it is highly suitable. Most of the cases the injection pumps are used means coupled with the automated irrigation system. Low price means and then it comes to medium and high. So, price is relatively high in case of the fertilizer injection pumps. Now, when we are talking about fertigation system design, one need to know what should be the fertilizer requirement, how to get the value of fertilizer requirement. So, fertilizer requirement can be estimated by using this expression, where we can get the recommended use of fertilizer minus the available fertilizer multiplied by the fertilizer concentration based on the what is the concentration it is needed. So, for each and every crop what is the available fertilizer concentration, accordingly this correction factor is multiplied and accordingly the fertilizer requirement can be estimated. When we want to estimate the fertilizer in each setting, how much is the fertilizer. So, amount of fertilizer for each setting or per setting in kilogram, it can be estimated by using this expression, which involves the distance between the emission devices multiplied by the distance between the laterals multiplied by the number of emission devices and then a recommended dose of fertilizer divide in kg per hectare. So, this is practically we will multiply divided by 10,000, it will depend upon the what unit we are using. So, if we are using in kilogram per hectare, then it is coming in that is to be divided by 10,000 because hectare is being used as a unit. Now, how to prepare the stock solution. So, stock solution means we need to know what is the concentration of particular fertilizer, nitrogenous fertilizer. So, let us say that we want to give 20 kg of nitrogen in a particular place. So, assuming that 20 kg of nitrogen is to be used for fertigation. So, amount of urea available is 46%. So, we will be, so in 20 kg the amount of nitrogen will be 43.5 kg you will be adding, and then there we will see what is the solubility of urea. So, 1100 gram per liter. So, we need to apply use 40 liters of water to apply the 43.5 kg of urea, and about 50 liter capacity container is enough to store 40 liters of water, which will be dissolving the 20 kg urea of means 20 kg of nitrogen which can be given. So, we will be using the siphon, the clear solution and injecting through fertigation applicator. Now, the another point is frequency of fertigation. So, what is frequency of fertigation means we want to give whether it is once in a day or once in every 2 days or once in a week. So, the frequency depends upon the type of system design, irrigation scheduling, soil type, nutrient requirement of the crop and farmers preference. So, injection duration and the fertigation in fertigation, what should be the duration of. So, normally the maximum duration of 40 to 60 minutes are recommended to with enough time for flushing and fertilizer residues from the lines before setting up the pump, and the maximum injection duration depends on which type of soil, what is the nutrient which we are giving and what is the water requirement of the crop. So, injection duration is sufficient for uniform distribution of your nutrients throughout the fertigation zone. Fertilizer concentration can be computed by using this expression. So, this is given by Fr by Tr by into Id, 100 is unit constant. So, if we are using the fertilizer concentration in ppm and then if we are giving the rate of fertilizer irrigation cycle in kilogram per hectare, and then the ratio of fertilization time to irrigation time is maintained, that is given by a time ratio, and then the grass irrigation depth is in millimeter. So, once we will calculate these numerical problems, you will get experience how to find out the fertilizer concentration, and then one can also find out the fertilizer injection rate. So, fertilizer injection rate QFI can be computed by using the expression, that is the rate of fertilization, that is the quantity of nutrient that is to be injected into the system, which is given in liter per hour, and then the area to be irrigated, that is area irrigated in hectare, in time say duration of irrigation is IT, and then which is in hours, and then C is the concentration of your fertilizer, that is in kg per liter, and then ratio Tr already I discussed you, that is the ratio between fertilization time and irrigation time, and IT is the duration. So, using this expression and these units, one can find out the rate of injecting a liquid fertilizer system into the drip irrigation system in liter per hour. And then one can find out what is the fertilizer tank capacity. So, fertilizer tank capacity, if I want to calculate in liters, then Fr is the rate of fertilizer per irrigation cycle, that is in kg per hectare multiplied by the area irrigated, and in time t divided by the concentration of nutrient in kilogram per liter. So, if you use these units, one can get the capacity of the fertilizer tank in liter. So, having got these data, one can find out these parameters which are required to design the fertigation units, fertigation components. So, refer these books which are given here. These books can be used as a textbook, and then also you can refer some of the notes which are available in internet. So, in this particular lecture we discussed about the theoretical aspect of fertilizer application method. We discussed about the design of fertigation system where the different expressions have been used, and then in the forthcoming lecture we will discuss about irrigation filters. So, we are means this is the concluding part of this lecture, and thank you very much.